So quite often when you're reading an exam question, you've got to think through what are the key trigger words and the things that will really say, get this word sorted in your head, or combination of words, and then the rest of the question becomes a kind of a logic process to get to the final answer. It's a starred question, so it's asking you to be really clear on your workings out, and we look through the language and we can see that it's talking about a straight line, so we're automatically thinking of y equals mx plus c, where we've got a line that crosses the y-axis through the intercept point C, and we've got a gradient that says for every one we go across the x-axis, or whatever the horizontal axis is, the gradient is the value we go up to meet the straight line again. And the gradient is defined by the change in the y-coordinates divided by the change in the x-coordinates. So we're kind of thinking through that that is a key part of this question. We're also thinking about the idea that it's talking about perpendicular. Well, what we've got to realise is that when they talk about perpendicular lines, then the product of the two gradients must equal -1. So that means we're going to have two gradients for line 1 times the gradient of the other line, and that must equal an answer of -1. So basically we've got to look at the information and try and find out these two gradients and see whether we get an answer of -1. If we do, then it's perpendicular. If we don't, it's not perpendicular. So we start with the first line then. So it says, is the line with equation 2y equals that? Right, so 2y equals 3x, take away 4. Well, we've got to compare that to y equals mx plus c. That means we need a single y. So basically we're going to divide by 2 both sides of the equals. So 2y divided by 2 gives me y. 3 divided by 2 gives me 3 over 2 x, and 4 divided by 2 is 2. We've got a negative, so take away. So that's the equation of line L. It's then given us two coordinates and told us that these will go through A and oh no, that's not the equation of L. No, because this is just the equation it gave us. Okay, so read the question carefully. Okay, so let's have a look then. So it's telling us these two coordinates are going through L. So basically we've got two coordinates. So A is going to be there roughly, 1 and 3. And B is at the point for -1. So for -1. So they're telling us that this is the line L and it's going in this direction. So we need to calculate the gradient of this line. Well, the gradient equals the change in the y-coordinates divided by the change in the x-coordinates. So this had a coordinate of 1, 3, and this had a coordinate of 4, -1. So the change in the y-coordinates would be 3 take away -1. So 3 take away -1. And the change in the x-coordinates, well, we've got to use it in the same order, so we did that, take away that. So we now got to do that, take away that. So it's going to be 1, take away 4. So this is going to give us an answer of, well, 3 take away -1 is 4, because take away the negative gives you a plus there, so 4. And 1 take away 4 is -3. So writing that neater, it's going to be -4/3. So we've now found the gradient of L. So the gradient, because it's an explanation question, start. So the gradient of L is equal to -4/3. So basically we've got to do 3 over 2 times -4 over 3. That gives us an answer of -12 over 6, which gives us an answer of -2. The two lines are not perpendicular, as the product of their gradients does not equal -1. Okay, so because it's a start question, we have to finish off with that sentence to say what we've concluded. So we went through, we recognise the general properties of a straight line. Y equals mx plus c will represent the equation of any straight line, c being the intercept point, m being the gradient, and the gradient being found by doing the change in the y-coordinates divided by the change in the x-coordinates. And because they said perpendicular, we recognise there's a rule for perpendicular lines that says the two gradients multiplied together must give you an answer of -1. So we took the first equation that they gave us and we compared it to the standard one, and therefore we needed a y on its own, so we divided by 2 to get the gradient of this line. So this told us the gradient equals 3 over 2. That was for that first line. We then sketched a picture to get a feel for what's going on with the information they gave us. They gave us some coordinates on the line L, so we sketched a picture, noticed it was a negative gradient, and then we used the rule for calculating the gradient of being the change in the y coordinates divided by the change in the x coordinates. So we went through doing the change, which is the difference between them. So 3 take away -1, and then 1 take away 4. I have to do it in the same order, so it's that coordinate take away that coordinate. And when we did that, we ended up with a gradient of -4/3, and that was the gradient of the line L. So there's our key information. The rule said the product of those two gradients should give us an answer of -1, but when we multiply these two gradients, we get an answer of -2. So we can conclude the two lines are not perpendicular, as the product of their gradients is not equal to -1.